So our next speaker today has been making websites since before CSS existed. He has seen the rise and fall of the font tag. He was born in Zimbabwe, relocated to the UK as a young lad. He has since become a Microsoft MVP, a conference favorite, and perhaps most impressively, a third-time Beattie and Code speaker. That's not bad. Worth an applause. And there's more to it. He has actually managed to get a programming language featured next to Iron Maiden in Classic Rock magazine, which is pretty unique in our business. Please welcome Dylan Beattie.
Thank you. Hello, Beattie and Code. How you doing? Right, I'm going to try and do 4 very difficult things now. 1 is I am trying to keep all of you awake for the next slot after lunch. 2, I am going to get you excited about cascading style sheets in 2026. 3, I am going to do it without talking about artificial intelligence and language models. And 4, I'm going to do it in 45 minutes, which is impressive because it's a 1-hour talk. And when I checked the agenda this morning, I'm like 1:15, and I was like, oh no, they need a break and stuff. But yeah, let's talk about CSS. Let's talk about the programming language that everybody loves to hate. Now, you know Stack Overflow, they do the thing every year. Which programming languages do you use? What do you want to work with the most? They don't even give CSS its own category. They put it next to HTML because it's got to have its big brother to stand up for it. Otherwise, it's... Who uses CSS? Like, who loves it? A lot of hands going down there. Some people are like, yeah, but CSS, it's not even a programming language. And you're like, why do you say that? And the goal is, it's not Turing complete. CSS is absolutely a programming language. Programming language is a thing that human beings use to make a computer deterministically do the same thing. People who say CSS is not a programming language, give them Hello World and say, hey, could you make this 72-point Cambria bold royal blue with a drop shadow? Thank you. By the way, you got to do it in Haskell. And those people will go away. But no, it's fair, it's valid. I understand. I've worked with CSS literally since it was invented. I've worked with a lot of people who've worked with CSS. And there are reasons why CSS makes people sad. First of all, you can't build software with it. Not on its own. CSS by itself doesn't do anything. You can't learn CSS as your only programming language. You have to learn HTML at the same time, which means once you get into it, you are having to learn 2 things, and it's like trying to learn Swedish and Danish at the same time. You know, like it would be way easier if you could just pick one of them, and no, you've got to do both of them, otherwise it doesn't work. So you can't build systems just with CSS, but you also can't get away from it. If you don't like Java, hey, come and do .NET. You don't like .NET? Hey, go and do Python. You don't like Python? You can do Perl. You don't like Android? Well, that's cool, we have iOS. If you don't like CSS, you can't really make websites, not properly. I mean, you can make, you know, Times New Roman websites, but it's inescapable. Now, people have tried. People have invented CSS in JS, which is like, no, you just write JavaScript. That's horrible. That is one of development's horrible mistakes. People have invented Tailwind, so you don't have to do CSS. No, Tailwind is an abomination. But a lot of CSS code is bad, and it's bad because developers don't like it, and developers don't do their best work when they are frustrated and unhappy, which means a lot of the code on legacy projects, code that's out there on the internet, is not well-written CSS. It is poorly structured, it doesn't represent good architectural principles. A lot of it is afterthoughts and hacks just to make something work. This, by the way, is what the language models have been trained on, which is why they don't produce brilliant CSS either. It's full of mistakes. No, really, it is. There is a page on the CSS Working Group Wiki, incomplete list of mistakes in the design of CSS, which is all the stuff that they say these should be corrected if anybody invents a time machine. And it's a long list, because there's a bunch of stuff in here that until it was invented and specified and in browsers and out there, we didn't know what people were going to use it for. And so we built what we thought, well, I say we, like, you know, the wider web community, what we thought people wanted. It turns out they didn't want that at all, but now we're kind of stuck with it because you can't go back and change it because the rule of evolving all this stuff, don't break the web. If there are pages out there that worked yesterday, they should still work today. Don't break the web. And finally, it changes all the time. And that's why this talk is rethinking. This is why it is important to reconsider CSS. Because like a lot of developers, I'm sure there's some folks out there, you learned CSS maybe 10, 15 years ago when you were learning how to build stuff and you were choosing a specialization. And then you moved more into back-end, or you moved into distributed systems or architecture. And so you knew CSS 10 years ago. You knew how to make it do things. You don't know about all the things which have changed in it. You don't know what the state of the art is. And so a lot of people, their perspective on what it can do today is informed by things which were true 10 years ago. Now, to understand how CSS got where it is, we're going to go back to the dawn of the web, the earliest, like this is the early 90s, before CSS existed, when there was NCSA Mosaic and there was the Viola World Wide Web hypermedia browser. And there is a lovely post. The web was supposed to present information, and it was created by scientists. And there is this lovely quote from an early World Wide Web developer mailing list. Someone posts, they think they found a bug. They're like, as you can see, Mosaic has added an extra blank line. Am I correct in assuming this is in fact a bug in the Mosaic rendering and that the links output is correct? And the reply comes in, that's not a bug, it's a rendering choice made by the browser. What can you do about it? Probably nothing. Isn't that cheery news? I think so. In fact, it has been a constant source of delight for me over the past year to continually tell hordes, literally, of people who want to, strap yourselves in, here it comes, control what their documents look like in ways that would be trivial in Tech, Microsoft Word, and every other common text processing environment. Sorry, you're screwed. Oh well, live and learn or not. Cheers, Mark. Do you know who Mark is? Mark is Mark Andreessen. He worked on Mosaic, he founded Netscape, he became a multi-billionaire, he was barefoot on the cover of Time magazine. This was Mark Andreessen in the early days of the web. Now, this kind of seems weird now, but you've got to remember, this is 1993, 94. Computers look like this. If you have ever seen a button on a computer screen, it is probably this button. Now, I think in a way this is something beautiful that we've lost, because any of you folks who built applications for Microsoft Windows, did you ever have to have a meeting about what color the button should be? Oh, it's a button. Microsoft has solved that part. Our job is where does the button go and what's written on it and what happens when you click it. Very, very clear separation of concerns. And so when the web started rolling out, it was intended to look like computer software because that's how you interacted with it. And buttons are familiar and they have what we call affordance. You see it, you know you can click on it. But then as soon as the web rolls out to companies and people with money and prestige brands and everything, they're like, we don't want our website to look like Windows. We want our website to look cool. And the state of the art when I first started doing professional web development was buttons with rounded corners. Because buttons were gray and square, so if your website had rounded corners, then you were cool and you were edgy. And the first company that I worked at, we charged money. We charged £10 for a rounded button because Paul had to make them in Photoshop by hand. And then we figured out, well, hang on, you can take an HTML table and you can cut the corners off the buttons and you can make a little table with 9 cells. And that means that the thing in the middle of the table, we can just put whatever text we want in that, and we're literally making free money out of HTML tables. And this is brilliant. Of course, a lot of other people went, yeah, we're going to do 9-slice table slicing, and rounded corners became widespread and they weren't quite so amazing anymore. And then the browser vendors come along and they're like, you know what? We're CSS, yeah. Border radius 4. Now, I say the browser vendors. What happened is that Netscape and Mozilla and Safari went, yeah, rounded corners. Microsoft went, you don't want rounded corners. No. Squares are cool. Microsoft built the Metro user interface, which didn't have rounded corners, because somebody at Microsoft must have gone, look, we can either completely reinvent the entire world of user interface design, or we can get Internet Explorer to do rounded corners. Which one's cheaper? And I went, let's reinvent the world. We've seen the IE code base. It's built on Microsoft Word. And of course, today, rounded corners, nobody cares. Like, if you want them, you've got them. And if you don't want them, you don't got them. And nobody really cares very much. And this is the cycle that drives the innovation of the web. First is how did they do that? Like, you see someone else's website or someone else's app, you're like, that's amazing. And then people write blog posts and articles about it. And then there are snippets and plugins and things you can use on your own site to do that. And eventually, when it kind of stabilizes, browsers go, yeah, you can just do that now. And then it's like, boring. What's shiny and new? But what I think has happened in the last decade or so, the web is built on 3 pillars: structure, presentation, and behavior. What does it mean? What does it look like? How does it work? And historically, structure is provided by semantic HTML. That's what gives meaning to the information that you're presenting. Presentation, CSS, makes it look a certain way, and JavaScript is what makes it work. That's what makes it move and stuff. And structure has always been paragraphs and forms and lists and headings, and presentation was colors and fonts and layouts, and behavior And this is what's happened, is I think we have realized, as the web has matured as an application platform, a lot of the things that we thought were behavior, like validation, like having a password box that wobbles if you get your password wrong, those are not actually behavior. They're not business logic. They are presentation concerns. And so CSS has gone, like, we'll take that. And I think this is great, because I think, the last time I did this talk, I said, the less JavaScript in the world, the better. And a lot of people on YouTube like that. That's not entirely true. But I think that, if you have logic in your front-end application that is doing something like, you got logic that calculates the price of a plane ticket or calculates someone's mortgage renewal, you don't want that logic running in the same engine that makes the button wobble because they didn't click it fast enough. So you want the JavaScript handles the logic your business actually does, and CSS can handle making things move and change color and wobble. Now, the other thing I got to pick up, the spelling on the slide is all over the place because I speak British English, which means I am constantly looking at words like color and going, well, that's spelled wrong, but if I spell it right, the browser doesn't understand it. Yeah, welcome to hell. I live here. It's delightful. Let's talk about accordions. Not the Weird Al accordions. We're going to talk about these accordions. This is a UI pattern. It's known as the accordion, and it's a bunch of headings. And what happens when you click on a heading, it opens up, and you get some stuff on it. And this is the one that ships with jQuery UI. And this is the one, Flowbyte is a module library for Tailwind, and this is the Google Material Design one. And accordions are cool. They're a well-established UI pattern for presenting, a certain way of looking at information. Now, did you folks know about details and summary? Because if you do this in your HTML, what the browser does out of the box with nothing on it is it goes, oh yeah, you click the summary, we expand the details. That's fine. You know about these tags? Because this is new, right? This is like some clearly just recently been added yesterday to browser standards. Now, if you want that mutually exclusive behavior, you give it a name, just like we do with radio buttons and checkboxes, and that's all fine, and now we can only open one of those at a time. Now, this is old. This stuff, there's a wonderful website, caniuse.com. We go on Can I Use, and we're like, hey, can I use details? And it goes, yes, you can. And you're like, oh, yeah? Widely available across major browsers. Oh, that's interesting. It must be a new thing. And then you dig into the details, and it's like, all right, well, it's been in that since 2016, and it's been in Safari since 2012, and it's been in Edge since 2020 when Edge was invented. It's been in Chrome since 2011. This has been there a long time. Like, details and summary goes way back. The detail here is that mutually exclusive, putting a name in it, that's only been widespread since September 2024. Now, unless you're paying attention, that is not a news story you're going to notice. You're not exactly going to go, wow, hey, everyone, look, on Hacker News, the details element is now supported. Unless you're following the fine grain of web standards, you're not going to realize that. But this means this thing went widespread. So details and summary, they are semantic. They're built into browsers. They are the right way to do this. None of those accordion controls use them. They just put divs inside other divs and figure that that's probably going to be okay. But it turns out that to do it that way, you need a lot of additional JavaScript. Let's take a look. So I got a slightly more involved example. I got a little summary paragraph and a bullet point list. These are some bands that I've been listening to. And we're going to put in some style on here. We're going to say, all right, the detail summary, that element there, we'll give it a cursor, which is the pointer, which is a little pointer finger. And suddenly we've got something renders like this. And we can open and close the panels on that, and that looks nice. And okay, let's move that down. And now we're going to say, all right, we'll put a margin on those so they don't butt up against each other. And now there's a pseudo element, the details content. It's not a real thing. It's not HTML, but it's there in the browser. And we can put a border around that, and we can give it a border style and padding. Now, that's applied it to all of them, which isn't exactly what we want. What we need is to say, no. Only the details element, which is open, should have this applied to it. And so now we get something which visually looks a lot closer to those JavaScript demos that we saw earlier. Now, you see there that the structure of the code? CSS can be nested now. You don't need to keep repeating yourself. You can put rules inside other rules, and this just works all the way down. Except if you want a pseudo element, we got to say, hey, that thing, put an ampersand, so we know that we're talking about a pseudo variant of the element we're already targeting. Now, we got this little gap here. That doesn't look good. We don't know what the first thing in the accordion is going to be. It could be an image, could be a list, could be a paragraph. So we can put a rule in here that says, look, whatever the first child of this is, take the top margin. Doesn't matter what it is. Just do that. And so now we get this much kind of nicer, cleaner layout. Now, we can plug in a couple of other little details and things here. I'm going to put a border radius on that. Now, that doesn't look very good, because you see when we blow it up there, kind of the corner? So we can go in and we can target individual subcomponents of these. We can say only put a radius on the summary of the one that's open, so we can do that, and that looks pretty good now. And now I can shrink this whole lot down, and I'm going to put a background color and a border color, and boom, now that looks like it does in the demos. Still no JavaScript. We're getting a lot closer to those things we were looking at there, and we've got this interactivity. Now, you remember those examples we looked at? They have animation. They move. And we want this to move, because movement is, if you like movement, movement is great. If you don't, you can turn it off in your browser, and there are ways to respect it. So I'm going to do a tiny little standalone demo now of something called a CSS transition. So we're going to build a dock. We got a bunch of icons for all of our favorite applications, and we got a little bit of CSS, and that is going to render like this. And what we want to do is we want to have those things get bigger when we mouse over them so you can see which one you're about to click on. So I can come in here, and I'm going to put a CSS rule that says when I hover over one of those links, I want the image width to go up to 128 pixels. OK, and now mouse pointer comes in, comes in, comes in. Where is it? Come on. There you go. Boom. Now, you see they snap. Like they go small, big, well, there's no transition. There's another cool thing we can do. I say, well, I want the ones either side of it to be a little bit bigger, so we get a kind of, like a bell curve effect. So hover plus A means find the hovering one and it's the next one. There isn't a way of saying find the hovering one, find the previous one, but there is a way of saying find one that has an adjacent sibling that is being hovered over, which is the has syntax, which is a new thing. So that says, look, if your brother's being hovered over, or if you are the sister of someone who is being hovered over, then change the width of that. I'm going to put an outline on these, just so you can see them. Outline, by the way, is brilliant because it doesn't change the layout. It draws a line around something, but it doesn't move anything out of the way to make space. So you can see exactly where stuff is, but then it won't mess your layout up when you take the outline off. So there you go. We got those getting bigger and smaller now. And then we can go, all right, transition all 0.2 seconds. And that just says anytime anything changes, do it nicely, do it smoothly over 0.2 seconds. And so now we hover over it and we get this really nice kind of transition. So what happens now is exactly what every developer does. You go, oh, this is amazing. This is so cool. I can do transitions. And the first thing you do is I can use that to build drop-down menus that drop down smoothly. So you have a menu here with a file element, and we got new, open, save as. And you drop the CSS in here, and you mouse over it, and it doesn't animate. And you're like, they lied to me. 15 minutes from realization to betrayal. Because it turns out that the problem is they didn't bake in support for what happens if you don't know how tall something is. And this might sound like a sort of relatively trivial thing. This is the problem. When we hover over that, the height changes from 0 to auto. And when CSS transitions were implemented, I don't know if they missed or it was just out of scope or it was too complicated. It doesn't work with automatically what's called intrinsic element sizing. Now, this is where we get to look into how the sausage gets made. This is the issue, the GitHub issue for adding transition to auto. This GitHub issue was open for 9 years. This was it being opened in 2016, about a year after this feature went mainstream. A couple of people going, yeah, that. And of course, immediately what happens is there is one faction going, well, we should just fix it. And there's another faction going, well, hang on, no, it's been shipped. Like, if we retrospectively change the way browsers work, we are probably going to break something. And 8 years later, L. David Barron posts this, which is an incredibly detailed analysis of websites that would break if we fixed it, which is things like Stack Overflow and Dell and Alibaba Cloud. Turns out that even if you ship behavior which looks broken, or doesn't, some people might consider broken, a lot of developers will embrace what they've got, build on top of it, and if you now go and change that from under their feet, stuff is going to stop working. And so backwards and forwards, and how do we do this? It is a fascinating thread. Like, you want to read through 9 years of Git comments about how the web actually gets evolved. And eventually, the CSS working group comes along, and they say, all right, we're going to give you a new keyword, which basically patches history to be what it should have been in the first place. And it says here, note, if we had a time machine, this property wouldn't need to exist. And so what we can do is we can go over. Now, if you just want to fix it everywhere, because that's fine, you have the root element, and you say, yeah, interpolate size, allow keywords, and there it is. If you have stuff on your website that would break, you can put that somewhere else. You can be far more specific in how you apply it. And so now we can go back over to our details and summary example. We can put interpolate size on, and we're just going to plug in a couple of rules about heights and transitions and things. And so now we get, well, it's a step in the right direction. One, it looks a little bit janky, because like the margins animate. We don't really want the margins to animate. Now 2, you get the animation when we open it, but you don't get it when we close it. Or you do, but it's already invisible. What's happening is as soon as it closes that element, it vanishes, and then it gets animated, but that doesn't work because we can't see it because it's already gone. And so we need to put in transition behavior allowed discrete, which says, look, if things are turning on and off, or if there are properties which can't be animated smoothly, hold off. Just give us a moment to do the animation, then switch them off. So that now gives us this kind of smooth open and close behavior. There's still a little couple of glitches about it. Now, the transition we've got on there, we're saying, hey, the height of this thing, if we want the height to change over 1 second using a linear animation curve and a 0.1 second delay, it looks like that. This is shorthand syntax for property is height, duration 1 second, timing function linear, delay 1 second. Now, shorthand syntax in CSS, if you break it out into properties and you want to put transitions on different properties, longhand, you say this. Okay, property, and then that, and then that, and then that. And then that one, da, 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 da. Now, you're looking at this going, that's not going to work, because you're going to go Shift-Alt-F in Visual Studio Code, and suddenly you can no longer see which timing goes with which property. And then you remove one, and now you're like, well, how does this even work anymore? So instead of doing this, what we do is we stack shorthands. So we say, all right, the color, I want you to do a transition on that. And the height, I want you to do this transition on that. And the border width, and then the first one is all, and that's your fallback. That's your default. It says if you don't override this later, that's the one you should apply there. And so doing this, we can now animate specific border, padding, transition properties, and we can even go to the extent of animating the border radius. And what that means is now we get this much, much smoother transition. But if I slow it down and zoom in, watch what happens to the corners there. Ah, see? That's why it's called beauty in code, because we can do that with no JavaScript. Let's see it again. You ready? Ah, isn't that pleasing? Yeah, this is your 10 seconds of joy, because you can't do that, because it doesn't work in Safari or Firefox yet. But this is what's, if you do this code in Safari and Firefox today, Firefox gives you this. It just doesn't support some of the transitions. Safari doesn't do anything. Safari just things snap open and close. But it's all still usable. All of the information on that page is still being presented, and the fundamental semantics of details and summary are still being preserved. You have opening and closing things. The point is, because this is based around standards, if you ship this code, in 6 months it'll magically start working in Safari without you having to push an update. That's the value of working with standards. That's what makes it so important, is the ability to say, no, we've done the right thing, the browsers haven't caught up yet. We're not going to exclude them completely. We're also not going to do some kind of weird sprint to just implement support for this one thing. We're going to do something that works well enough. Now, whether that works for you, it's down to you, your users, your product owner, your budget, but I like the approach. I like that idea. Or you can go a step further, and you can put the supports at rule and just say, look, if the browser supports this syntax, interpolate, size, allow keywords, here is extra CSS. And if it doesn't, just hide it. It's invisible. The browser never sees it. Let's have a look at some more interesting stuff. You'll notice in the little demo that I did there, I was using named colors. All the colors I used had names, like royal blue and Gainsborough. You'll know what color Gainsborough is, right? Because you learned that in engineering school, yeah? When the web first launched in the 90s, it launched with a set of 147 named colors. And these were popular because they were accessible. And if you want to know where they came from, Netscape got them from X Windows, X11. And X11 got them from a file called rgb.txt, which had been floating around on Unix systems for a couple of decades. And that file was created by 2 engineers on separate occasions in separate companies. One of them sat down with the Sinclair Paints catalog, and another one got a big box of crayons. And they just sat there one night and typed in the red, green, blue color values, and this is where it came from. Now, only 2 colors have been added to CSS since that first specification. The first one was orange. There's a guy called Eric Meyer, who is a champion of open web standards. Eric wrote a lot of the demos for CSS version 2, and he used orange because it worked. And they realized late that orange worked because browsers supported it. It wasn't in the spec. So they hurriedly ran back and went, better put orange in the spec. And then the other one that's in there, this is Rebecca Purple. And Eric's daughter Rebecca, she very sadly died of a brain tumor when she was 6. And the CSS community went, why don't we put her favorite color in the spec as a memorial? And they did. And that's where Rebecca Purple came from. And this is CSS named colors they're human. They have stories behind them. We've got Dodger Blue, which was the color of the Dodgers football team in one of those paint catalogs. And we've got Burleywood and Firebrick. We've also got gray. And we've got dark gray, which is a little bit lighter than gray because they came from different places. And these are all based on, how many of you folks can read the little hex codes underneath the color names there? Because this is a syntax we adopted for expressing colors. If the one you need wasn't in the Sinclair Paints catalog in 1987, you could mix your own color using red, green, and blue. And RGB is a color model it's based on how computers draw color. Because on your screen, you've got little red lights, green lights, blue lights. And if you want to turn on all the red lights, you can. And if you turn on all the green lights, you can. And if you turn on all the blue lights, you get blue, and if you want colors in between, you have to kind of twiddle the metaphorical dials and things. Thing is, this isn't how humans think about color. It's how devices treat color. For humans, this is a much more intuitive color model. The hue is, what color is it on this color wheel here? And then the saturation is how much, and the lightness is how dark. And this, to me, this is just a much more intuitive way of working with palettes and tones and building user interfaces and all of those kinds of things. Now, CSS has always allowed you to build red, green, blue colors and hue, saturation, lightness colors using percentages or using numbers. And then they went, actually, no, you know what? That's deprecated. How about we do the exact same thing, but with spaces instead of commas? And everyone went, why would you do that? And no, it turns out there is a really good reason for it, is that they needed a way to, the old stuff still works. It's deprecated, but it will never stop working. Otherwise, so much of the web will stop working. But they needed a syntax which could be extended to do something called a relative color calculation. Now, if you have ever been shopping for fabric or paint or something, because you're redecorating your apartment, and your partner holds up a cushion and goes, we need this cushion, but green. And the cushion is purple. But you know what they mean? Because like maybe it's a really vivid purple, and you're like, right, we need a vivid green. Or maybe it's a very kind of delicate. So this is plum, and we can be like, all right, well, we want a background color which is from plum, but we want to change the hue on that color wheel. Or we want a background color which is from plum, we want it 100 degrees on the color wheel. So we can build procedural palettes by extrapolating from other colors. So we could do, all right, well, let's set a base color. This is a CSS variable, by the way. By the time CSS got variables, all the good ways of naming things were already being used for something else. So CSS variables work the same as comments in SQL, which is fine. So base color plum, that's a variable. And then we're going to say, all right, well, all the paragraphs in this document have got a background color that is from, read the variable value of the base color, and then do a calculation, which says 20 multiplied by, now sibling index, you can figure that out. First one's 1, second one's 2, 3, 4, 5. And so that gives us, look at that, procedural rainbows, which is rather nice. Now, if we do the same thing, but instead of plum, we say the base color is red, we get this, which is very kind of bold and vivid, but it has a problem. Because if we were generating background colors for buttons on a web page or something, and we put some text on top of those, which one of those is more readable? Yeah. Now, this is where things get weird, because meat is involved. Because computers are like, it's fine. Physics is like, it's fine. The human eye is like, if you throw the same amount of energy at me, but you do it at a blue wavelength, I'm going to ignore some of it. If you throw the same amount of energy at me in the green and the red part of the spectrum, I'm going to be much more responsive. We human beings, we see blue as quite dark, even when there's a lot of energy in the color. We see yellow as being a lot brighter because it's a mix of red and green. And so there are different color models that correct this problem. There's a thing called lab, which says, well, never mind RGB and stuff. We'll have lightness, and then where is it on the A scale, which goes from green to red, or the B scale goes from blue to yellow. There's the H hue, whiteness, and blackness saturation. A single LCH, which is lightness, chrominance, and hue. And then in 2020, during COVID lockdowns, a Swedish guy called Björn Ottosson, who is a developer, musician, and problem solver, man after my own heart, he went, you know, these colors aren't okay. I'm going to make ones that are okay. And he made OK Lab and OK LCH. And that's why they have those names, is because he went, they're okay, which is very wonderfully Swedish. And these are really, really useful color models, because if we do our rainbow example using the OK LCH color model, we now get this consistent tone of lightness. Now, the reason why this is such a powerful engineering tool is if you're building like, a web store or a content management system or that kind of thing, your users, your customers, they will want to choose their own colors because otherwise you have to build different, you love it. But you don't want to let users choose colors. Users shouldn't be allowed to choose colors. Users should be allowed to choose color. One, singular. And you should generate everything, because if users are allowed to choose two colors, they will choose two colors that don't work together, because that's what humans do. So what you want to do is say, look, you pick your favorite color on this, and then we're going to use something called a tetradic color model to come up with 3 other colors that we know are going to work beautifully alongside it, and that's going to be the palette that we use to build your new web application or your storefront or whatever. And I love this because if we take these tetradic color palettes, have a look at what these look like applied to something sort of akin to a real web layout. So we've got a hero image, and we've got some typography and some buttons there. And as we change the position and the delta angle there on the tetradic color wheel, you can see the demo on the right-hand side is changing to reflect those. Now, one, I think that's quite neat because it demonstrates the principle. Also, that's a web page, and it doesn't have any JavaScript, because it's all CSS animation. Now, let's take a look. CSS animation is lovely because it lets you build keyframes and all kinds of things. So we're going to say we've got a heading 1, position absolute, left, border radius, padding, all fine. Background color is lime, which is this nice green color. And then we're going to say, all right, I'm going to define a set of keyframes. They're called the moving H1 demo. That's my name. I chose it. And I want you to go from left 1 rem to left 20 rems. Do you know what a rem is? A rem is the width of a capital letter M in the root font that's used on that document. It's a good unit because if somebody has enlarged their text because they are visually impaired or they're working on a very, very fine pixel device, all the rems get bigger, and so everything scales up with the text, and so you get a UI that doesn't fall apart when you magnify text. That's why it's a good idea. So now we're going to say, all right, H1, I want you to animate this over 2 seconds, and we get, whee, snap. Oh, hang on. Whee, snap. What we need to do is, once you've finished animating, leave it there. Don't bring it home again. It can stay. It can stay over there. And so we put a rule in animation fill mode forwards. Like when you run out of animation, which direction do you go in the timeline? And we say move it forwards in the timeline. Just roll it forward from where it is. So this now gives us, well, what if we said instead of just going from here to there, what if at 0% we want it to be here, and at 20% we want to be over there, and then at 100% we want to be over here? So now we can control the timing. We can have fast, and we can have slow, and we can have different kind of animation curves, and we can animate multiple properties. So we can say, all right, well, at 0% background color is gold, and the border radius is 1 rem, and then at 20% background color is going to change to sky blue with 2 rems, and then at 100% the background color is purple. Also, the foreground color, change that to white, and the border radius goes to 0, and now we get that. So you can animate multiple properties. Now, 1, you don't have to write the JavaScript. Good idea. 2, you are declarative. You're like, no, don't you do the maths. I'm just going to tell you what I want and where. 3, most of this will get offloaded to the GPU. So it's not going to block up your main JavaScript thread. It's going to run really quick. If your GPU has native hardware transforms, it'll get dumped onto those. This means you save battery life on your phone, which means you don't need to get your power bank out on the train. This is just a good thing if this is the kind of stuff you're trying to build. Now, let's take a look here at an example of, I'm going to put some variables. So I've got a variable here called angle, because we've got a color wheel where the angle is how far around the color wheel, and we've got something spinning. Let's make those the same thing. So I've got an angle that's going to go from 0 to 360 degrees, and then I'm going to put an animation on the root. So the whole document, I just want to change the variable of the value of that variable, drop all those in there, and ta-da! Nothing happens. Because making CSS do what it should do is often hard because there's already something in the way. We need to put in one more thing, is we need to tell the top-level runtime engine, look, we've got a variable that's going to change. We've got a property that has this syntax, it's got an initial value, and also tell it, does this inherit down the cascading style sheet and cascade onto child properties, those kinds of things. Once we've told the browser, hey, we're going to be messing with this, you keep an eye on it, now we have things which can change angle and color at the same time by setting both their geometric transformation and their hue on the color wheel to the same angle, which is how this thing here works. Those things there are being animated based on that color, and so are all of the color variables on the right-hand side. So how did we build the color wheel? Well, CSS has backgrounds. It has linear gradients. that look like that, and it has radial gradients that look like that, and it has conic gradients that look like that. And if we draw an element which has a border radius of 100%, which means take the corners off completely, make it a circle, make it round, width and a height, and give it a conic gradient, we get this. And then we're like, okay, well, once you've drawn that, draw something else immediately after it. I want you to draw empty content, but this one, you're also going to put a border radius. You're going to give it a width and a height, and you're going to give it a white background and a black border, and absolute position it so it's smack in the middle of the color wheel that we just drew there, and that's going to draw that thing over the middle of it. So that conceals that thing for us. Now, you can do a whole lot more with CSS backgrounds. Like a conic gradient, when people think about gradients, they think of smooth, like, like almost like a watercolor wash effect. But you can have hard boundaries in CSS gradients. We can have a gradient that goes from there to there to there to there, which is like, okay, that's pretty cool. But now look at what happens if we give the background a size. Because here we've said I want that conic gradient. I want you to draw it starting at the top left, and I want each gradient to be 32 by 32 pixels, and that gives us a checkerboard pattern. If you've ever had to go through an entire website trying to work out which images are actual transparent PNGs and which ones just happen to be the same as their background color, you can do it in one rule. Now, I wouldn't do this for customers, or they'll get confused, but it's really useful for troubleshooting. Or we could go in and say, well, I want you to do a radial gradient with a hard stop. That's going to draw you a circle, and I want you to repeat it, and now you can have web pages with polka dots on them. Or you can say, you know what? I want you to draw a linear gradient which is just white. You can't do solid color in this. You just have to do a gradient with one color. Don't ask me. I think it's a hack. And we want you to do a linear gradient that is going to be transparent to 31 pixels and then one little stripe of sky blue. But yeah, also then draw another one, which is the same thing, but instead of being a gradient to the left, it's a gradient to the top. And so now you can have web pages that look like graph paper without having to use graphics on it. Or you can take our pal Mr. Fluffy here, and we can say, all right, auto 100%, right center, no repeat, there he is. Let's draw another layer on top of it. So what I'm going to do here is I'm going to say, okay, background image, linear gradient white, but then I'm going to use a background blend mode, which is called saturation. And this says, I want you to take that image, and for every pixel, I want you to saturate it using the saturation from this layer. And white has no saturation. So this is how you turn a color photograph into a monochrome photograph. And then we can drop another layer over the top, and we can say, well, let's give it a nice rainbow gradient here. And this one, the blend mode, take the color from that layer and apply that to the other layer. And now we've got rainbow fluffy. Or we can do our OK LCH from var base color, get the color based on our brand guidelines, drop that and extrapolate that, and that's how we do the color tint. And so that's how your users can give you a color photograph that you can use CSS to knock the color out, desaturate, and tint it so you can use it as a hero image that goes nicely with the brand guidelines you're using on that particular bit of the site. And as Mr. Floofy says here, let's build something cool. You know the coolest thing that I've seen built in CSS? And this goes right back to the comment at the beginning about CSS is not a real programming language. This came out last week. This is lyra.horse/x86CSS. It is an x86 processor built in CSS with no JavaScript that you can run programs on. So you can write programs in C and tell the C compiler to compile them and then take the binary byte code and upload it to this web page, and it will run them incredibly slowly because CSS is now sufficiently featured. Now, don't do this, of course, because this is a horrible idea. And if you need to emulate an x86 CPU, there are so many better ways to do it than pure CSS. But the fact that it's possible is just, you know, the state of languages, their capabilities, and the number of things they can solve. Next time someone says, oh, we have to do that with JavaScript because CSS can't do it, maybe be like, hang on a second. We can do a lot more in CSS than you possibly think. Now, to me, the most significant outcome of the development process, the transparency, the GitHub issues, the working groups, and the CSS working group wiki and stuff, is not being able to build an x86 browser in CSS. That's cool, but it's not important. What's important is that the standards that govern the web are public. They are transparent. They are out there where anyone can get involved and anyone can see how they happen. Now, the web is dominated by a handful of browsers. Chrome, Safari, Microsoft Edge, and Firefox. And actually, Chrome and Edge are the same browser. And all of these, Brave, Opera, Arc, Samsung, Vivaldi, the UC browser, which is one of the biggest ones in India and parts of Indonesia, these are all Chrome. These are all really just the same Chromium rendering engine. So if Chrome can do something, they can all do it. And if Chrome can't do it, they can't all do it. And Chrome is maybe open source or maybe controlled by Google. It depends on your particular kind of ethical lens through which you view these kinds of things. But the fact that the web is being built on open standards which are transparent and documented means if you wanted to build a completely new browser, in theory, everything you need to know to make it work is on the internet in machine-readable text. So you could point your AI assistant at it and go, build a browser, Claude, or whatever this was, Cursor, and give it all the tokens, and then leave it for a week. And they tried this. Cursor tried this in January, and they went, ta-da, AI built a browser, and you're like, did it, really, now? And they went, well, it kind of works. It still has issues, and of course, very far from WebKit Chromium parity, but we were astonished that simple websites render quickly and largely correctly. So any of you folks wanting to look forward to the glorious future, as long as you build simple websites, then AI-coded browsers will render them quickly and largely correctly. Now, AI is changing so fast, I'm sure give it another couple of weeks, couple of months, bits of this problem are going to be solved. There are kind of, actual serious projects out there to build completely new browser engines. Servo is a project originating in Rust to build a high-power embedded browser engine. It was a collaboration between Google and Mozilla. What happened in 2020 is they fired all of the developers working on it and then gave it to the Linux Foundation. Like, do you want this? It doesn't have any engineers, but we thought you might want it. But this is still kind of chipping away. The one which is getting the most attention is a browser called Ladybird. And Ladybird came out of a thing called the Serenity operating system. It's built in C++. It is intended to be a completely fresh code. It's not pulling in libraries from any of the other browsers. A completely new browser engine. I tried to get Ladybird working because I wanted a screenshot for this demo, and it's our first alpha is coming for Linux and macOS this year. It's not there yet. You can't find screenshots. You can't download a binary. I was like, I can build it on WSL, so I spent an hour in the hotel last night. Basically, build it, error message, ask Claude about the error message, do what Claude says, build it again. Eventually, I gave up. And the reason I gave up at this point is because it was telling me that the lagom linker supports linker was true. And I thought for a Swedish audience, the lagom linker is probably a nice note to end on there. So yeah, keep an eye on Ladybird. A lot of people are very excited about it, probably because they've seen it running. I haven't, but yeah, that looks like fun. But like I said, it's really important to me that there are enough open specs that the web is not being evolved by Apple going, ta-da, we did a thing, and everyone else scrambling to catch up, and then Google going, ha-ha, we did a different thing because we didn't like your thing, which is how it used to be. Microsoft and Netscape, that was how the browser wars happened. Hopefully, from now on, it'll be open standards, collaborative transparency. Now, this talk has scratched the surface of what modern CSS can actually do. There is so much amazing stuff out there. There are grid layouts, there are flexbox layouts, there's animations and transitions, there's anchor positioning, which is how you stop your tooltips falling off. That's new, that's just come out. I am going to take a moment to plug something. I'm running some workshops, and one of them is about how to do talks like this one. If you want to know where the ideas come from and how to make slides and all that kind of stuff. One of them is all the stuff that CSS can do, and grid positioning, and layouts, and anchor, and all that kind of stuff. And then I'm also doing one which is kind of sprinklings of this alongside a lot of hardcore stuff about building web apps in ASP.NET. This is all at dylanbeattie.net/workshops, so go on and check those out. It'd be lovely to see some of you there. I used to have slides where I was like, follow me on social media, and then social media all turned into a giant pile of crap. So I have a mailing list. And at the moment, it is such a low-volume mailing list that you can reply to it, and I will reply back to you. So absolutely, if you want to know where I'm going to be, and courses, and YouTube stuff, and events I'm speaking at, and just bits of music and tech and stuff I think is cool, so join my mailing list. I send out about 1 email a month when I get around to it, and I will not sell your email addresses, because I don't know any people who buy email addresses who would do that. Folks, are there any questions? Ah, the silence of enlightenment. I love it. Yes, we have a raised hand. They're bringing a mic over. Hang on.
What's your favorite browser?
So my favorite browser, I used to run Opera a long time ago when everyone else was running Netscape and Internet Explorer, because Opera had their own rendering engine. It was very good for standards compliance, and it cost money. And I liked the fact that instead of, like my browser company, I gave them £50 to use their software, because then I knew where their money was coming from. Opera eventually kind of fell by the wayside, and then they ported it, and now it's just another skin around Chromium. My daily browser is Google Chrome, just because that's the most common one. If you're doing web development, you don't want to do your work in an esoteric browser and then find it doesn't work for normal people. I used Brave for a long while, and then I stopped using that because the monetization model turned out not to be interesting, just to be massively exploitative. I used Vivaldi for a while, and then at one point, I think I just repaved my laptop and forgot to install it. But Vivaldi's nice. Vivaldi's the Chrome engine wrapped up in a UI. It has an email client. It's a Norwegian company, I think, one of the Norwegian, Swedish, certainly Scandinavia. One of the engineers who used to work on Opera founded Vivaldi, and it's a privacy-first browser, but under the hood it does the same rendering stuff as Chrome does. I think Opera, old Opera, like Opera in the late 90s, early 2000s, that was the most interesting browser because that was the one where it was an actual commercial enterprise going, you don't need to be a trillion-dollar multinational to browse the web. We're just going to build a browser and put it out there. But those days are temporarily gone. Maybe they'll be back. We don't know. Any other questions, folks? Yes?
In one sentence, what did you cut for time?
Had to turn a drop-down into a radial pop-out thing like you'd see in computer games. I can show you it in 15 seconds if you want. Did I delete the slides or did I just hide them? It's all right. I've got the copy of the talk that I did in the last conference, and they're still in here somewhere. And So you know how people for ages have been like, oh, look, it's a drop-down list, and we want the drop-down list to not look like a drop-down list like Microsoft Windows does. And so CSS said, look, you can do select, pick up, back as base select, and then it goes this, and you can style that bit, and 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 that bit, all independently targetable, which means you can have drop-down lists that look like this, so they're different colors, and they got little spinny bits and stuff. But also, I saw a demo Brecht de Ruyt did, so credit to Brecht for this one, which is a CSS drop-down that when you click on it, it does that. And that's the HTML for it, and that's the JavaScript for it. And actually, I'll leave that one there because there's a QR code where you can go and grab the code for that. Thank you very much, folks.